Well, thank you very much for having me. I'm delighted to be part of your group now. Like Fabiola, I'm interested in the universe and the fundamental story of it. And I'm driven by questions like how galaxies formed over the last 11, 12 billion years, and questions like black holes and their action in these galaxies. Now, this is, on the one hand, astronomy, of course, and the other hand, it's for me, it's also experimental physics, because we're trying to use modern tools of experimental astronomy to get at these questions. In fact, what we've been doing in the last 40 years is very much associated with some of the academicians. May I first mention Martin Rees. Martin's work in the 1960s and 70s was stimulated by the discovery of the so-called quasars, very luminous, very distant objects. Nobody knew what they were. And Martin and Donald Lindenberg proposed that they might be very massive concentrations, black holes, very much what Einstein's theory had predicted, but nothing had been seen, but very massive, millions to billions of solar masses. And to prove that, one had to really go ahead and look at more nearby objects, because these objects are much too far away. Here comes in the story of another academician, namely Charlie Towns, a Nobel laureate for the Meson laser, who in his later years got interested in astronomy. And when I joined Charlie's group in Berkeley, at that time we started measurements to prove through dynamics of gas initially, and then later on we used stars to basically ask the question whether there might be such a massive black hole in the galactic center. Now, this is a long journey. I mean, things usually don't happen in front of your eyes in astronomy. In the galactic center, they do. And the third partner in this journey is Pierre Lénard, who invented a number of the experimental techniques in Europe, which has made possible to make such precise measurements that nowadays we can not only do the astronomy and answer Martin's question, are these really truly black holes in the sense of Einstein's theory, but actually start now playing with them like in a laboratory, and in fact using these very strange objects to test the theory itself on scales of masses and dimensions which really had not been possible. And you have to understand that not only we, of course, there are others like gravitational waves. 100 years after Einstein's theory, it's now actually the time when we are beginning to really test this theory in some great detail. So this is a wonderful time, very far away from us, of course, but a fascinating story. So I'm very, very much honored to be with you.